Hi everyone. This talk is going to be about Luca's amazing blog in theory, and in particular, I will talk about some of my favorite blog posts and their influence on me. But first, I'd like to say a few things about my favorite papers of Luca. So I was Luca's postdoc during 2012, but obviously I've heard about him much earlier. I did my master's and PhD at the Weizmann Institute of Science. And among our faculty were Irit Dinur, Uri Feige, Oded Goldreich, Moni Naor, Ran Raz, and Omer Reingold. So obviously, our training included a lot of pseudo-randomness, PCPs, and hardness of approximation. At the time, it seemed like Luca's papers were simply everywhere. As a graduate student, I remember that I particularly admired his seminal paper with Madhu and Salil on pseudo-random generators without the XOR lemma, which discovered the connection between hardness amplification and the error correcting code. His beautiful paper with Salil on the randomizing BPP under uniform reductions. His fascinating paper with Omer and Salil, which shed a lot of light on the RL versus L problem. And of course, his breakthrough paper, extractors and pseudo-random generators, which revealed the connection between extractors and pseudo-random generators, and eventually led to the understanding of extractors as a type of error correcting codes. And of course, Luca had many more great papers, but these ones particularly influenced me as a graduate student. But of all of Luca's creations, the one which I enjoyed the most was Luca's blog in theory. So this blog started in 2006 when Luca traveled to China and created the blog in order to tell his friends about his experiences. And about a month after the blog started, Scott Aronson summarized the blog by saying, Luca is finding travel reports from Beijing, where apparently the food is excellent. To which Luca replied, where were his powers of synthesis when he was writing his thesis? With time, Luca added much more stuff to the blog, including more travel reports and food reviews, amusing anecdotes, his take on American politics and Italian politics. By the way, several of his posts are about the Silvio Berlusconi, who used to be the Italian prime minister at the time. And when you read these posts from today's perspective, you have to admire the Italians. They had such a leader way before it was mainstream. On a more serious note, Luca also wrote a lot about gay rights, feminism, and the mission of Berkeley as a public university to provide higher education of the highest quality to working class students. And of course, one notable example of his writing about gay rights was his series of Turing centennial posts. In order to celebrate the Turing centennial in a way that commemorates the gay aspect of Turing's life, Luca invited the gay theorists to write about their experiences in the community, resulting in a series of 8 posts on the subject. But of course, the thing that the blog was probably most famous for was Luca's masterful exposition of topics in TCS and mathematics. While as a student at Weizmann, I already knew a lot about expanders. Reading Luca's exposition of expander graphs and spectral graph theory reshaped my understanding of those subjects. And it was also from Luca's blog, from which I learned about the many connections of TCS to additive combinatorics, and on important tools such as the regularity lemma, Gauss uniformity, and ergodic theory. Another subject that Luca was fond of was going beyond worst-case analysis, and I learned a lot from his blog about this subject as well. And of course, these expositions are just the tip of the iceberg. This blog is filled with eye-opening explanations of many ideas in TCS, mathematics, and the connections between them. But perhaps my favorite part of Luca's blog was his philosophical musings. He wrote about the scientific community, the research process, and how science works in general. There were 4 posts that I liked especially and I would like to talk about today. A People's History of Mathematics, On Being Second, Positive Knowledge Proofs, and The Vision Thing. Now I will now talk about these posts in a bit more detail, and I will use a lot of direct citations from his blog verbatim, just because he wrote so well. So let's start. In People's History of Mathematics, Luca starts with a common misconception of the scientific process. Many histories of science and mathematics are premised on the view that bothers me a lot, that at any given time there are a lot of people chugging along doing incremental work, and then once in a while a great person, usually a great man, comes along and starts a revolution. Then people start chugging along in the direction dictated by the revolution. Luca proceeds to explain the error in this view. And that these breakthroughs, these discrete advances, are not made by geniuses who magically produce an entirely new discovery. A major advance happens because the time is right, because the work of all the people beavering away has completely clarified the number of tools that were previously less well understood, because a large collection of incremental results and observations has been made, and all the pieces are there, ready to be put together. Of course, this is something that is known on some level to every experienced researcher, and yet I think it is important to articulate it, and no less important to tell it to graduate students. And this was one reason why this blog was important for me. Then Luca proceeds to say something that was new to me. This is not to detract from the people who actually make great contributions. Indeed, realizing that the time is right for an advance and that all the pieces are there and that they can be put together is an amazing skill, which is pretty much what people mean by genius. What I particularly liked about this text is that it gives us an interesting view of what a scientific breakthrough is. The act of putting together a lot of pieces that are already there. I never thought about breakthroughs in this way before, and I found it very interesting. Luca proceeds to discuss how the internet and the Polymath project in particular could be used to facilitate more breakthroughs. And in general, this is a very interesting post, and I highly recommend it. In the post On Being Second, Luca observes that sometimes the second paper on a subject is more influential than the first one. He writes, after the first paper on the problem, the community may still be skeptical about the importance of the problem. After the second paper appears, however, the problem becomes an area, and it becomes considerably more appealing. It points out to the most famous example, which is the Karp's paper on NP completeness. Indeed, while Stephen Cook proved the NP completeness of SAT in 1971, it was not until the paper of Karp in 72 that the community became interested in the notion of NP completeness. And then Luca gives a few other examples. The research on hierarchy theorems using small advice, basing average case complexity on NP hardness amplification in NP, pseudo-random generators in NC0, and approximation algorithms for unique games. And the full post develops this idea in more detail, and I really recommend it. And it ends with the following memorable conclusion. Unimaginative theoreticians of the world unite and pursue problems that have been studied only once You have nothing to lose but your time. In positive knowledge proof, Luca discusses the question of good mathematical writing. Starts with an observation that is familiar to all of us. Even if a proof is written such that all the technical details are clear, and we can verify its correctness, it might still be the case that we do not really understand anything from it. It's kind of a real-life zero knowledge proof. Then Luca points out the following. Although we sometimes write a proof with the main goal of establishing that a certain result is true, this is hardly the reason why we read proofs. We read proofs with the hope of learning something new, a technique that can be applied elsewhere, an insight about the nature of a certain mathematical object, and so on. Luca proceeds to develop this point further and suggests to define good writing by analogy to zero-knowledge proofs. In a zero-knowledge proof, we require that after seeing the proof, the verifier cannot do anything that she couldn't do before seeing the proof. Luca therefore deduces the following criterion for good mathematical writing. In order for a proof to have positive knowledge, it must give the reader the ability to do something new. And I think that this perspective is very original and interesting. I have read several texts on good mathematical writing, and I have never encountered this idea before. Luca also discusses a criterion due to Gowers. A proof is well presented and in general well understood when every step in the proof looks natural and in fact inevitable. And while this idea is due to Gowers, as a student I read it on Luca's blog, and it informed my thinking about both research and teaching ever since. Finally, in the vision thing, Luca discusses the role of vision in theoretical research. He starts by discussing his aversion to the word vision and of the notion that research can be planned in advance. The word vision evokes to me images of people who are full of themselves and who think that research can be planned in advance. These are feelings that I've always shared with him. There is something that seems paradoxical when people ask me about my future plans, or when I don't even know what I will be working on in 6 months ahead. Indeed, as Luca writes, as theoreticians, we know that the only answer to the question, what will the great advances in theory in the next 5 years, is we don't know. Because if we knew, we would be making these advances now, and it would not take 5 years, and they would not be such great advances after all. But still, it seems like dealing with our vision in research is unavoidable. And having some sort of vision sounds like it should be a good idea, right? In this post, Luca approaches this subject in what I think is a really nice and well-articulated way. I think it is very useful for a theoretician to develop their own ideology about theory, to get a sense of what she thinks are the long-term goals of the field, of how particular research programs fits into these goals, and of what constitutes helpful progress. It is also extremely important for the community itself to go through the process of defining such goals and to explain the way in which current research fits them. Indeed, I think that this is perhaps the most reasonable way to approach this issue. And this articulation by Luca helped me thinking about this subject ever since I was a student. So these 4 posts were maybe my favorite posts, philosophical posts of Luca, but he also had a number of other interesting posts of this kind that I also highly recommend. In What Good is an Log Approximation, Luca tackles the question of the usefulness of theoretical research to practical algorithms. In particular, he presents an interesting agenda for going beyond worst-case analysis. In My Gut is Better Than Yours, Luca tackles the question of how we can claim that the subjective taste of experts is better than the subjective taste of the layperson, which seems kind of paradoxical since taste well is subjective. But Luca still explains why this assertion is true, and this post also, and he uses a beautiful anecdote about modern dance. And then there is the post on Paul Erdos and Kim Kardashian, and if the title of this talk doesn't make you want to read it, I don't know what will. And basically what Luca does is in this post is to examine the literary archetypes that great mathematicians and celebrities fill in modern society and in the scientific community. All those posts are written with Luca's trademark combination of thoughtfulness and witty humor. Finally, those of you who were around in 2008 probably remember the controversy about conceptual contributions. Luca wrote his position on this controversy in 2 posts, giving American flags and conceptual contributions to orphans, and what makes a mathematical proof hard. While I'm not sure I agree with his position, his posts provide a thoughtful and well-articulated discussion of the values of different conceptual and technical contributions. Okay, so these were a few of my favorite posts. Let's wrap up. Luca will be missed for many things, for his scientific brilliance, for his amazing expositions, his sense of humor, and for his humanity and kindness. One of the things that I will miss the most is his full reflections on science, on our community, and on the research process. I hope that these few examples illustrate why I feel this way. Goodbye, Luca.